here that we get the green O and the hex O here, and I want to show you that in the environment. Okay, let's bring that up here. And here's an O, and it turns white, and it turns yellow, and it turns green. Well, words do that. White, yellow, green. You can turn a word on or off in the middle of your program, and you can use your program as if it were a configuration file of your program. A second kind of O changes from yellow to hex yellow to green, or small number green to hex green. Is that small number green? Let's make sure. We can fetch the block, and there it is. It's a small number green. It's tagged with a 6. And later on we'll get into tags, but it's tagged with a 6. And that means it's a small letter green. And so, I'm going to bring us now to an earlier block in the system. There's 20. Right after the first word in the system, swap, which needs to be defined early because it's used early. It's used in store. And I imagine store would have been higher up here in the hierarchy, except that it also uses if. And so if is here. But 0 is defined right after swap, and it's used in fetch. Fetch is probably defined before store because originally you might want to look at what's there before you store something there, I would assume. These other words are all part of the hierarchy here. Here's address store. This stores into the EDX register. This fetches from it, puts it in the A here. Fetches from it, puts it in EAX. But this 0 right here, we'll talk about really quick. Skipping over the question dupe, which is a special optimization word. We have an Intel Pentium operation code here, 31C0, which has the EAX register XOR itself, which causes it to clear itself to 0. So 0 in the system, defined as a red word and not as a number, turns out to be both. Church numbers can be built on top of this number, for those who know what church numbers are, and it has implications for a color-forth list, I would assume. Okay. Getting back to our program, you'll notice I changed this 8 from yellow to green. That was necessary because if I don't, if it's yellow, when I load the program, it still works. Oops. That wasn't supposed to happen, I don't think. Let's see. Oh, it crashed. Yeah, see, it crashed. It wasn't supposed to work, and it didn't. Ah, look at that. That's another colorful project for its heading around. I didn't do that on purpose. That was unintentional. Let's see, maximize here. Okay, 818 edit, and notice I hadn't saved. So because I didn't save before I executed that little nicety, it crashed, but it didn't save the crash info. I can start the program now, and we're not going to crash. We're going to be okay for a while, showing this sentence. colorAssembler is a run crash system, and this is why it's so important to build your program one piece at a time, changing one thing at a time, and testing it every time. And I think, I know that Chuck Moore was having a genius moment when he put this thing together, because this factors code, it promotes code into Pentium ops eventually if you want to go that far. And it Okay, so it crashed because this was yellow. We'll try that again. It's running, put an 8 on the stack there. And then when I hit the space bar, it crashed. Okay, so now I'll turn it back on, and because we didn't save, remember we said it would be okay. And now when we run, it's fine. And I'm going to expand this window. Okay. So let's talk about factory code. I'm going to probably take this a little quicker now. We've got a sum word. It'd be nice if we had a subtract word. So let's have a word called diff, and it basically does the same thing, I guess. Get, swap. Print. We need to go to icons and get the icon. 35. Okay. 35. Read yes. And we can put a little white there. And we can have all that. Because we're going to go to that. Okay, so we show our sum. We can change that if we want to. We can put in here diff. Turn that word white. Remember we said we could turn something on or off. Oops. And now it's a subtraction. Okay. Well, we could probably make this a bit more convenient for ourselves as well. Why don't we try this? Alright, some diff, we'll get rid of those. Each word will itself be an okay word. Copy that. Copy those. So I missed a word here. Alright. Let me get rid of this okay word now. And now we can just call up the display as sum or diff. Okay. That little artifact there. And so we saw one kind of crash, and there's several kinds of crash. The one kind of crash we were able to replicate quite easily. I'm certain that through this series you will run across the rest of them. Another one leaves us with only this, with this window stating there's trap fault. And then the window doesn't politely dismiss itself like it did in the last crash. Dismissed itself, if you please. In this case, where we have a trap fault in the window, and there are a couple of situations that can happen. One, the system's frozen, and the way to remove the system is to call up that block right there and use the close to close it. And we'll bring it back up. Okay, and that's a safe thing to do.